Thanks for sticking around, everyone. I'll do my best to keep this entertaining. I'm aware that I'm between everyone and the after-work beers, so we won't run this too long. I'm going to be talking about AWS security at scale. You could subtitle this talk, How Not to Get Breached. The plan here is to talk a little bit more about the specifics of what really gets people breached in practice, rather than all the best practices that security consultants like me usually like to waffle about. A little bit about me to start with, though. I'm a principal consultant at WithSecure. You probably knew us as F-Secure up until a little while ago. It's now the business arm that broke off and has been rebranded. I've been in the security world since about 2014 or so, mostly as a penetration tester originally. Now I do a lot more varied kinds of consulting on both the offensive and defensive sides. AWS Community Builder, do a fair amount of talking. If you've been at security events in the Helsinki area before, you might have seen me, but this is my first time at the Nordic Community Day. So what am I going to talk about? I think first up, some common misconceptions, then unpick some common real-world breach scenarios, look at a breach data set, what's really getting people hit in the wild, dig into what we see as security consultants, the kind of flaws that I run into when we're helping our clients out, and things that attackers haven't got to yet, but that we expect they will eventually. Some key security controls from my experiences that have really made life harder for us when we're trying to attack things when we're in our offensive mode. And lastly, a piece on how best to engage with third-party security providers, some advice on what not to do when you're buying penetration testing, all of these kinds of things, because I think the industry is still a little stuck in the past on that one, and it's mostly our fault. So this is me helping you out, making sure you get the best of it. First off, though, bit of an acknowledgement. I am very well aware that usually when someone stands up and talks about security, you get a big rant about lots of things that sound like they're still stuck in 2005. The hope is that this isn't that, but it's still very, very prevalent. It's really common for me to go into organisations and hear that sort of, it's just someone else's computer attitude from someone inside security, or find that on the defensive side of things, security monitoring, the security operations centre teams, detection engineering, they're all working on the idea that everything's still virtual machines and you can stick an endpoint detection and response agent on it and everything's going to be fine. Clearly that doesn't really work once we start doing serverless and Kubernetes and all these other things. So I spend a reasonable amount of my time trying to help organisations out of that. And then when I get lucky, work with some more cloud-native organisations where this is much less of a problem. But at the end of the day, the reason that sort of attitude becomes massively problematic in a lot of especially larger organisations is that attackers don't really care about where the data is or how your estate's laid out. They just want stuff, right? So it's really common to see cloud breaches initiate as a phishing attack. So we got someone launching a phishing attack, either stealing some credentials, dropping some malware, and then pivoting up into the cloud from there. We're seeing more and more attackers target the cloud directly. S3 buckets, obviously, a common breach point. I'll get into that in a bit. But often people leave stuff lying around and you can pivot further in from there. It's also becoming more common now to see people start targeting, or attackers start targeting, cloud environments and actually pivot back down into an on-premises estate from there because they were able to find something lying around in the cloud, be it some credentials or there's an open VPN route or something else that allows that pivot. And that one in particular, I think, is something that would be your average SOC's worst nightmare, because they'd have a hell of a time trying to spot it in the first place. And by the time an attacker's already finished rooting around in your cloud and he's got back on premises, we're in a bad state. But that's not to say it's the end of the world, right? There's a lot we can do about it. So before I go into the breach scenarios, there's a few points that are worth making, I think, overall about a lot of this stuff. Attackers are always looking for the easiest path. Unless you're working for, the Finnish Defence Forces or something where there's an obvious target on your back for high-end nation-state threat actors, for the most part, it's someone coming along looking to make a quick buck, do some ransomwaring, something else like that. So they're opportunistic. They're looking at you amongst thousands of other organisations. The other important thing to note is a lot of the basic controls make life much, much harder for also those really sophisticated attackers. One of the best examples actually was the SolarWinds breach a few years back. Some of you might remember. That was all unravelled because someone noticed an MFA prompt on their phone that they weren't expecting. They got a prompt because someone tried to add a new MFA device, turns up on their phone, they reported it to their corporate security team, and it unraveled a multi-year Russian intelligence operation. So get the basics right, because it'll help you everywhere else too. And most people do get screwed by the basics. We'll unravel that more as we go through, but public S3 buckets is the obvious one, but leaked credentials, people putting the administrator access managed policy on stuff where it shouldn't be, all these kinds of things. And at the end of the day, you're probably not going to get breached by not having your encryption at rest configured. The auditors aren't going to like it very much, but it's probably not the cause of your security problems, really. There's always a lot of talk at AWS Reinforce and places like that about shiny new security features like Nitro enclaves and things like this. Nice to use, maybe. Is it ever the cause of a breach? Well, we'll get into that in a second, but probably not. You're also probably not going to get hit by some crazy zero-day that breaches AWS at the sort of the control plane layer and ends up stealing your data that way. Again, we'll get into more of that in a second, but I don't think I've yet seen any of that in the wild. And equally, you often hear, especially in highly regulated environments, people being very concerned about insider threats within AWS. So an AWS employee going rogue and trying to steal an organization's data, not really realistic again. AWS have an awful lot of checks and balances to balance that out. So again, not one that I'd be worried about. But what happens in the wild? What are attackers really doing? To work on that, I've grabbed a copy of Rami McCarthy's breach data set, which is available up in GitHub. And he's been curating for a while now a list of as many public incidents as he can get his hands on. Also, a lot of incident reports published by incident response firms, anonymized stories of what they've run into in the wild. And so that's given me a data set of 45 breaches going back to 2014, 21 incident reports from security firms who've had to respond to them. It ignores all the open S3 buckets because we'd be well into the several hundreds for that one. But it's a good data set to work with for anything else, right? But when we unpack that and we look into it, it's important to remember that this data set is inherently flawed. A lot of breaches never get spotted at all, especially where they're more interesting ones, or they're using more advanced techniques because they're going to bypass the standard detection mechanisms like guard duty. AWS are definitely the worst for this, but the other providers aren't much better either. They don't like talking about security breaches that happen in stuff that they manage, right? If a customer gets breached, it's not in their interest to tell people because otherwise people get scared. Right, you go along to Reinforce and it becomes quite apparent that the entire point of the conference is to convince people that they can be safe in AWS. So it's counterintuitive for them to talk about it, which means it's only if an individual company decides they're going to talk about it publicly or they're forced to for GDPR reasons or whatever, that we ever actually hear about it. So this might be where some of the bias here comes from, but while the Cloud Vulnerability Database is tracking over 120 flaws that have been found in AWS, Azure, etc., at the control plane layer, we've only seen one exploited in the wild that's been publicly reported, and that wasn't the cause of a breach in the end, I don't think. So this, I expect, will change in time. There's a lot of firms out there now who are maintaining really quite sophisticated cloud security research teams who are digging into this quite hard. Wiz, for instance, have been churning about an O-day or two a month out in one of the major cloud providers for probably 18 months now. So there's a lot of really interesting work going on in this space, and eventually it's going to be the cause of a breach, but not for now. And if this topic's of interest to you, discovering new vulnerabilities and how people go about doing that, Wiz's Forward CloudSec 2022 keynote is well worth a watch. They spend a lot of time unraveling how they do that research and the kinds of things they look for. Really quite interesting. Now, I said we'd exclude S3 buckets from the discussion for the breach data set, but it is still by far the biggest source of breaches, right? So AWS have a ton of controls in place now to help with this. Buckets aren't public by default anymore. That was a big change that was long overdue. And they've got that fantastic checkbox for block all my buckets from being public in this account. And if you take one thing away from here, go away and check that in every single account you possibly can, because that's a really easy box to check in most cases, and it will block a significant percentage of the breaches that we see happen in AWS. So, into the actual data set. What are the major causes here? There's quite a few categories that I've broken it down into. One of the interesting ones there in particular is unknown, because a lot of the breach data that gets reported is, we had a breach, we're not going to tell you what happened, we're not even really going to tell you actually what happened to the data or anything that was accessed by the breach. We're going to give you a bare minimum that's required of us under GDPR or similar. So we don't really know the details of a lot of these, but you'll see between the insider threat sections, public credentials up on the top right there, and leaked and stolen credentials, probably over half the breaches are somehow tied into credentials. And that's backed up by the reports you see from security vendors like Verizon, who do a data breach and investigation report every year. And they estimate about 70% of cloud breaches are credential-based in one fashion or another. And that's been fairly steady for quite a few years now. It's often people putting AWS access keys in public repositories. Sometimes you'll find it's insider threat and former employees. That's a bigger percentage than I was expecting personally, but that's pretty common. And then perennially, phishing will always be a problem, I'm sure. It applies to AWS too. When it comes to managing credentials, I would say that people problems are actually the biggest part here, right? There's a lot of things that aren't technical controls that are the cause of a number of these breaches. It's people forgetting to disable a contractor's access when they leave, and there being some kind of disagreement, and the contractor gets angry and then decides to do something nefarious with the access they've still got. It's hard to prevent genuine insider threat. If you've got an employee who's dead keen on doing some damage, that's a really quite hard thing to stop. But sort of 15-20% of those breaches would probably have been stopped if someone had disabled the right accounts when someone left the company, right? So make sure that your joiner and leaver processes cover all of your different ways you access your cloud, all the single sign-on systems, access to the code bases, all of these things. It's surprisingly common that not everything's accounted for there. And equally, secrets management is really hard. People end up leaving credentials in source code, not because they want to usually, but because they've got nowhere better to put it. It's a really common theme for us, to the point where we used to joke about how a lot of our breach simulations would basically, the methodology would boil down to a single slide that just said passwords that we'd steal from Git repositories or open SharePoint sites or whatever else, and you'd be amazed at how far you can get with that. And it's because fundamentally it's hard to work out where to keep them and how to store them effectively. AWS give you Secrets Manager, which is fantastic. Make good use of that. Equally, parameter store is pretty good too. But it's a hard problem. That said, one thing that I really wanted to highlight here, IAM users. Can I get a show of hands for who's got IAM users active in their AWS accounts right now? Who's brave enough to, there we go. All right, so that's probably half the room. Of that breach data set, 44% of the breaches that they disclosed the details of included either an IAM user, access keys, etc., as an initial access point, or they were used by an attacker to pivot or deploy a mechanism whereby they could get back in later, a persistence mechanism as we call it. So if you can block IAM users, that does a huge amount for your security, right? My attitude towards IAM users these days is very much nuke them from orbit, right? Especially now that we've got IAM roles everywhere, we've got a number of these other mechanisms that AWS are providing to allow you to assume roles and use IAM roles for things. There are vanishingly few cases where you genuinely still need IAM users. So look to identify those and then track what those IAM users are doing very carefully. Put like an elevated threat level on them in your security monitoring so that you're paying more attention to them because there's a good chance that a breach is going to start there. Other interesting vectors that we've dug into over the years, things that I've exploited personally on engagements, interesting attack paths. Single sign-on. So how many people here are using Okta or Ping or OneLogin or one of these other cloud-based SSO platforms? Okay. Azure Active Directory? There we go, there's a few more hands. So actually, if you're using Azure AD, you're in a much better place than with many of these, but quite a few of these single sign-on platforms apply lots of controls like multi-factor authentication and the IP address you're logging in from and all these things when you create a session. But they don't then check where that session is used later on, right? These tools all generate web cookies of some kind. They embed them in your browser or they get stashed in your AWS CLI somewhere. And that cookie is then never really validated again once it's been generated. And so if an attacker is able to steal that out of your laptop, I mean, we've done that and used it from like a random DigitalOcean box we spun up to talk to AWS and via... I forget which one of those it was, one of those up there. And that got us into the AWS estate, and the single sign-on provider just let it happen, and that was all fine. So it's a bit of a supply chain risk too, right? If Azure AD ever got breached, I think we'd all be in some fairly serious trouble. But at least with Microsoft behind it, you can in theory be reasonably sure that they're doing some decent security work on it. And to give you an example of how that then plays out, this is a composite of a few different things we've done with clients over the years, but the thread remains. So we've got an initial breach point with a phishing attack on a developer, and we've used that then to pivot up into AWS. We've stolen that session cookie, we've logged into AWS. From there we have a poke around, and it turns out they're using Systems Manager, Session Manager to manage their EC2 instances, because let's face it, if it's a big organization, there's probably still a few EC2s around. At that point, I really like Session Manager as a way of managing EC2, but it does join your security domains up. IAM then becomes the key thing that also grants access into all these instances at the operating system level. And so then we were able to use that to create an SSH terminal or session inside one of these systems, and off we went from there. And it turns out one of them had a database full of super sensitive information, and so that was game over for that particular attack we were simulating. Now, the other interesting area for me is all of these continuous integration and deployment tools and Terraform Cloud and all the other things people build their cloud engineering platforms off, right? A lot of this applies a lot, or allows you to apply a lot of extra security, and you can do some really quite smart things with it. But also, if you get it wrong, we're then in a position where an attacker who can change your source code also changes what's going on in production. And it's really common for me to find cases where what's deployed into production in the cloud is really well hardened, but the systems doing the deployment and the source code management systems and things haven't seen anywhere near as much security attention. And so therefore, if an attacker's in a position to manipulate those, that bad things happen. And one of the key balancing points here, or challenges, is around usability for engineers versus security, right? We can't have security come in and stop engineers working. No one wants that. But we also need to balance that against the fact that some security probably needs to be there somewhere. So that obviously depends on an organization's appetite for risk. It's going to be very different in a heavily regulated financial organization versus a game development company, perhaps. But you have to have those discussions and work out where that risk appetite, where that risk acceptance layer is. And any kind of automated infrastructure as code deployment is often a favorite place for us to start looking for ways in. So in this particular scenario, we were asked to see what would happen if we stole a developer's laptop. If we had an open laptop that got picked up in a coffee shop, where could we go from there? So we've got a developer level of access with a developer laptop. And from there, we started poking around inside GitHub, and we find some infrastructure as code repositories. Who here is using Terraform after Anton's talk previously? I'm guessing we've got a few at least. Fantastic. Okay, any Terraform Cloud users or Atlantis? Okay, maybe not then. So the way these operate is that they are tied into your source code management system, and when a pull request is open on a Terraform repository, they take the contents of the pull request, they run a Terraform plan, and they return the results as a comment to the merge request or pull request saying, hey, these are the changes that would be made if this was to execute. What that means in practice is that Terraform Cloud or Atlantis has some AWS credentials that it's using to talk to AWS to work out what will change, and it is also compiling and running the Terraform to all intents and purposes. And you can use Terraform's external resource type or custom Terraform providers or a few other things, basically to allow for arbitrary code access, or code execution, sorry. So we're able to embed like a bash script in your Terraform that we can then have do whatever we want, right? So we run that in the context of Terraform Cloud by opening a malicious pull request. That gets us the AWS credentials that Terraform Cloud's using, and off we go to administrator access in production. So a lot of these development tools that really help speed up the rate at which you can develop and engineer in the cloud also have their security downsides. It's important to understand and balance for that. But in terms of what do, how do we apply sensible restrictions, where are the key security controls to focus on? Identity management is one of the big ones. If you take another thing away other than the open S3 buckets thing, multi-factor authentication everywhere. Security's been banging on about it forever, but please do it. Principle of not very much privilege is something we've coined fairly recently, because principle of least privilege is mostly a fool's errand to chase after. It's like the pot of gold at the end of the rainbow. No one ever gets there. But if you can get to a stage where you are at least being reasonably sensible about the permissions you're applying, and where you're adding more permissions to stuff, sensibly thinking about why and if you can maybe not. I've already done the piece on IAM users and IAM roles, and if you're in a position where you're having to manage lots of credentials that aren't tied into AWS, then doing what you can to automate management and rotation is generally a good thing, but it's often a lot more engineering work than the other things on that list, so there's a reason that it's at the bottom. Then when it comes to access to production, how many of you as engineers can log straight into the production AWS accounts running your workloads? Oh, that's fewer hands than I was expecting, but it's still probably about half. That, to me, is always a bit of a red flag in some respects if you can just jump straight in and do it. But at the same time, it's obviously quite a lot of engineering to get to the stage where that's not a thing that you need, right? So robust observability, Anton was talking about some of that earlier on, but having the ability to generate enough data out of production that you don't need to log into it to go poke around and work out what's gone wrong is really important. And in an ideal world, your CI/CD pipelines would be fast enough that you can respond to an incident by pushing changes in the normal fashion. Not always possible, but it's a nice place to aim for. There will obviously then still be cases where someone's got to log into production, so you want some kind of production access control mechanism. Often that's like either a pod in a Kubernetes cluster or a Bastion EC2 instance or something like that, that you can then monitor and audit the commands run within it and all of these kinds of things to make sure that when an engineer is getting into production, you know it's happening, you've got some idea of what they're doing while they're there, all of these good things. And then for the really top tier of this, then feed all those logs straight into whoever's doing your security monitoring, if you've got a security team, so that those logs are then available should something bad happen, and you can actually go and reverse engineer what someone did inside the account when they were poking around. Secrets management is hard. I said that one earlier, but it's worth reiterating. It's often the key point of failure. People don't understand where their applications store their secrets, so there's a lot of secrets being passed around. So whatever you can do, use Secrets Manager, use Parameter Store. They're there for a good reason, right? And when you're designing applications, always be thinking about what credentials does this thing need, what's it talking to, how do we grant access to those credentials to it, how do we know if those secrets are leaked, do we have any kind of monitoring on our Git repositories in case someone pastes it in by accident. All of these kinds of things. No one's ever going to get this perfect, and a lot of organizations won't even get it that right, but it's worth thinking about, because again, if as an attacker, if I can find this stuff lying around, it does make things much worse. Now, security testing done right. This is the result of some discussions that we've had over the last little while in the AWS Community Builders Slack and the Forward CloudSec Slack workspace, which is about sort of 3,500 cloud security professionals. Hopefully this will inspire some better collaboration. So penetration testing in AWS often looks something like this, right? We've got an application we're running, and it's running on AWS, so we need to do some security testing on the application to make sure it's not full of like SQL injection vulnerabilities or something else that's going to disclose all your sensitive data. We want to test for some business logic flaws to make sure that your workflows work the way they expect to. And then you'll see people talking about sort of cloud configuration reviews or cloud pen testing, where we'll have a poke around and look for common configuration mistakes that Security Hub could probably have picked up, a look at your IAM configurations, network layouts, security groups, what traffic's allowed where, these kinds of things, and come up with some recommendations as to places that they can improve, or if you've got something really wrong, find that at that stage so we can fix it. But there's a few problems to this approach, to my mind. These are often done every 6 months or on a big new release or things like that. They're largely driven by audit requirements, not by risk or threat. People buy them because they need the regulator to feel warm and fuzzy, or because one of their investors is doing their due diligence. Realistically, if you're getting a test done every 6 months or every year, cloud engineering these days, everything moves too fast, right? I work with a number of organizations who deploy tens of times a day, and so if you're doing a pen test every 6 months, the amount of changes that have happened since the last pen test You have a big window there where something bad might get introduced, but you're not going to spot it. Generally, from the perspective of the engineering parts of an organisation, they're not getting very much for their money. They're getting a bunch of recommendations that are valid at that point in time, but they're also happening after all the architectural and design work's been done, everything's been implemented, and just at that point, we're catching the issues, and now we've got to go back to the start to fix them in some cases. And it often ignores all the critical supporting systems. People don't generally bother pen testing their CI/CD pipelines, source code management, single sign-on, all of these kinds of things. So what do we do instead? So automate as much of it as we can. That's something that I think a lot of us in the cloud security world are pretty familiar with, but it's also, we do a lot of that in the cloud in general, right? So apply it to security too. And then where we're bringing humans in to do things, use them to do the things that we know a computer can't currently do. ChatGPT is probably going to jump on my back in a couple of years and remove half my work, but for now at least, there's a lot of stuff that the automated systems still struggle with. So use humans to fill the gaps. So in terms of automation, there's a few things that we can do here really. So from a configuration perspective, Security Hub's great, but there's also a couple of great open source tools that will catch common mistakes for you. Prowler's pretty common. I see Scout Suite a fair bit as well. From an infrastructure as code perspective, if you are indeed doing infrastructure as code, scanning things in the pipelines before they reach the deployment stage is a really good idea. And Chekhov's my personal favorite for that, but TF-Lint's pretty good for Terraform too. IAM's an area where the automation's still struggling, but there's at least a few tools that can help you understand the risks of what you've got configured and things an attacker might do with it. Cloud splaining is a really good one for that because it embeds a whole load of explanations as to what these risks it's flagging are and actually why they matter in an engineering context. So that's well worth a look. And lastly, secret scanning. Trufflehog's a favourite for that one, but essentially you can run these on Git repositories and it'll flag where you've got access keys embedded in or there's a certificate lying around where it shouldn't be or things like that, so that you know to switch them out and rotate them. Then, what do we use humans for? Two things, one of which is what I'm calling human-led reviews. So we're deliberately targeting things that computers have a poor understanding of, or they're not in a position to assess right now. So things like understanding how all the SCPs and your identity and access management configurations operate organisation-wide in the context of what you're trying to do as an organisation and what your apps do and all of these kinds of things. Looking at all of your single sign-on configurations and the various groups and permission sets, CI/CD, source code management, as I said before. These are all good areas to bring in someone to take a look at directly once you've got the automation covered off. And lastly, objective-driven assessments. And what I mean by this is cases where we've got a business-level risk. We've got something like key IP that we want to make sure that stays secure, or maybe we're processing a lot of personal information and a GDPR breach is going to be bad for us, so okay, let's set that as the goal, or moving money between bank accounts, these kinds of things. We're not talking about technical objectives, but business level ones, with some realistic starting points. So, either an insider threat or a compromised laptop, or perhaps we start with access inside an app server or a Kubernetes pod to simulate some kind of application level vulnerability, and then target into the rest of the environment from there with a goal of hitting one of these business level objectives. That said, you might have heard the word red team before, or the phrase red team. These have been sort of a buzzword in security for a long time now, and they're seen as the sexy things for consultants to get involved in because you get to cosplay as a nation-state threat actor for the afternoon. You probably don't need one. A lot of organisations in the security world are very keen on pushing these are good ideas. Sometimes they are, sometimes they're not. But what they're good for is validating your detection and response capabilities after you're already sure that the rest of your security is up to par. It's never a good place to start. So before you get there, make sure you've got all of your basic configuration stuff covered off with Security Hub or those open source tools. Make sure you've built out effective detection and response beyond just turning guard duty on and hoping for the best. There's a bit more to it than that as well. Then run the previous type of engagements, these objective-led things that I've talked about there in a collaborative manner, sit the engineers down virtually next to the tester and have them work together to make sure that everyone understands what's going on. You'll find an awful lot more that way. And then once you're fairly certain that all of that is in place and that you're pretty happy with your overall security posture there and that you can detect and respond to things, then at that point it might be worth considering one of these. And in terms of collaborating with people like me or many of the other security consultancies out there that organisations buy this sort of work from, if you're going to buy a pen test, make sure that you're doing the best you can to make it work for you. A lot of organisations in the security world are keen on shipping big PDF reports that you then have to unpack and put into your issue trackers and things. Push them to produce things that fit into your dev workflow. Right, have them upload all the contents directly into your issue trackers or these kinds of things. And where they're giving you advice and telling you how to fix things, make sure you're pushing them not just for the fix for the one issue they found, this S3 bucket wasn't encrypted or what have you. Ask them for how you can make sure that doesn't happen again. Look at the systemic ways to fix whole classes of problems at once. And any good security consultancy should be able to help you work that out in the context of your organisation and environments. It's really common for a lot of organisations to say they do cloud penetration testing, and a lot of the time it's old school pen testers who've been doing the on-premises stuff for decades, and someone handed them an AWS CLI and they said, oh yeah, I can do this is great. And that was me about 5 years ago, to be fair. We've all been there, but make sure when you're digging around trying to find a good partner to work with, make sure you as engineers are on these discussions and it's not just your managers having them, so that you can weed out who really knows what they're talking about with AWS and cloud security versus who's just sounding like they do. And equally, another really good thing to look for is, can they show you novel research and development in the security world that's related to whatever it is you're building or to AWS or the technology stack you're using. Most good security consultancies will be out presenting at conferences and publishing research on their blog and all of these kinds of things. So if they're not talking about things that are relevant to you, treat that as a bit of a red flag. And equally, from my perspective, it's always best to collaborate on these things as much as possible. The one thing I really hate is I sit down and I'm on an engagement and the client hands us a bunch of credentials and says, all right, see you in a week, give me the report, Work with us on it. Talk to us, help us understand what you're trying to do, how you've ended up where you are, flag potential problem areas that you already know about, talk to us about what the best solution is going to be for you in your environments, the context of what you're trying to build. And that will help us make sure that what we produce at the end of it is as useful to you as possible. Equally, I often hear organisations saying, oh, we want like a complete, no information, black box, start from the outside on the internet and try and break in. And you can do that, but it costs a fortune and is largely a waste of time. You're far better off giving the consultants direct access, at a read-only level at least, into the AWS accounts they're looking at so they can understand how everything's configured. They'll find more problems for you that way. And equally, if you are using Terraform or CloudFormation to build all this stuff, give us access to the source code too, because again, we can use that to speed up what we're doing and find more problems for you. So to wrap up, all of that stuff I was saying about source code management, CI/CD, all these kinds of things, they're often the key weaknesses in the organisations that I assess. If they're not going to get breached by one of those things that we talked about in the breach data set, that's often the common point. That or IAM misconfigurations or secrets management are the three things I'd really focus on. Good security in the cloud relies entirely on automation with some smart humans doing things on top of it. So if you've not got the automation in place to find the problems, you're going to be spending more money than you need to and more people's time as well. Look to be smart about where we bring humans into the security process and look for every opportunity to try and build automation to at least spot the security problems where we can. I'm less of a fan of automated remediation. It tends to break things, but we can at least spot the problems so we know about them. And lastly, the security community is very good at rocking up and saying, hey, look, we broke everything, and sort of mic drop and walk off the stage. It's really not an attitude I think we as an industry can continue having. And this is a proverb that someone at Microsoft dug up, John Lambert, one of their security engineers, distinguished security engineers. If you want to go fast, go alone. If you want to go far, go together. If we're going to make cloud a more secure world to operate in, that requires security people like me to work with engineers like all of you to make it that way. So thank you for listening. If you've got any questions, I think we've still got a couple of minutes.